Hello student, this is question from JEE Advanced 2026. This question is from the chapter Liquid Solutions or simply Solutions. The question is, in a solvent S, a compound B is partially dissociated into C and D as given below, B giving 2C plus 2D, B, C and D are non-volatile in nature. The molar mass of B is 10 times the molar mass of S. The standard boiling point and the standard enthalpy of vaporization of S are 400 Kelvin and 10 R joule per mole respectively, where R is the gas constant in joule per Kelvin per mole. The solution of B in S with the initial concentration of B as 0.25% mass by mass has a boiling point of 0.408 Kelvin at 1 bar pressure. In this solution, the mole percent of B that has been dissociated is, so we have to find the what percentage of B is dissociated to give 2C and 2D. So we have the equation B giving 2C plus 2D. You have to find the percentage. If you find the Vant Hoff factor, then you can easily find the percentage dissociation. So if initially it is 1, then we have alpha of it is reacted, then the remaining amount of B is 1 minus alpha. The amount of C formed is 2 alpha, amount of D formed is 2 alpha, and iota I for or the Vant Hoff factor for such reaction is, you have to make the sum of these all values. So we get 1 minus alpha, so this is 1 plus 3 alpha. So if we find the value of I, we can find the value of alpha as well. And by multiplying the alpha with 100, we get the percentage dissociation. So what informations are given? I'm using the one by one. So the molar mass of B is 10 times that of S. So you can take the values as well. You can assume any values. The answer will not change. So the molar mass of B is 10 times the molar mass of S. I am taking this value as 10x. Its molecular weight is 10x and molecular weight of S is x gram per mole. I am taking these values, and the standard boiling point of this solvent. So S is the solvent here and B is dissolved in it. S is the solvent. This is our solvent and B is dissolved in it. So we have boiling point of B is 400 Kelvin. And next we have the latent heat of vaporization, or the standard enthalpy of vaporization is nothing but latent heat of vaporization is 10 R joule per mole. It is 10 R joule per mole. This is values for per mole values. So if I convert this value to joule per gram, so we have formula of Kb. You have to use the formula of Kb as well, and the formula of Kb is equal to R T naught B square, standard boiling point of solvent, divided by 1000 LV, latent heat of vaporization in joule per gram. So we have to use this value in joule per gram. So this value is for 1 mole, that is 10 R is the value for 10 R. Joule is the value for 1 mole means x gram of S. This is value for x gram. So I can write this value as 10 R. So for 1 gram it will be 10 R by x joule per gram. So I'm putting this value here. We get Kb is equal to R. T naught B is 400 Kelvin, so its square will be 16 into 10 to the power 4 divided by 10 to the power 3. LV is 10R by X, 10R by X. So this value comes out to be 10 to the power 4 cancel out, R cancel out. This is 16. So value of Kb is 16x. And next we have a solution of B in S with the initial concentration of B. Initial concentration of B is 0.25% mass by mass, has a boiling point of 408 Kelvin at 1 bar pressure. So finally the boiling point is 408 Kelvin. So we have delta TB, elevation in boiling point is 408 minus 400 Kelvin. So this value is 8 Kelvin. This value is 8 Kelvin. And next we have to find the molality. So we have delta TB is equal to Kb into molality. So value of Kb is known. So for finding molality, we have 0.25% mass by mass or weight by weight of B in S. If I take 100 gram of S, then we will have 0.25 gram. If we take 100 gram of solution, then it will have 0.25 gram of B. This is solution. And remaining the 99.75 gram is of solvent S. So I am approximately taking this as 100 gram because solving with this value is really difficult, and JEE Advanced anyway gives the values in range. So I am taking this value as 100 gram to make our calculation easy. So for finding molality, we have number of moles of B. Molality is number of moles of B divided by mass of solvent in kg is 0.1 kg. Nearly 0.1 kg. So we have molality is equal to, this is 0.1 kg, and number of moles of B is given weight 0.25 gram divided by its molecular weight is 10x. So we have number of moles of B is equal to given weight 0.25 gram divided by its molecular weight is 10x into 0.1. So these are the number of moles and this is 0.1. So we are getting this value as 0.25 divided by x. So I multiply this molality here. So this formula is iota times kbm. Delta TB is I Vant Hoff factors times kbm. It is 8 Kelvin. So we have 8 Kelvin is equal to I into value of Kb is 16x into molarity is 0.25 by x. So this x cancel out and we get iota is equal to iota into 16 by 4. 4 is equal to 8. So value of I is 2. Vant Hoff factor for this reaction is 2. Not exactly 2. If you put the exact value, this value is less than 0.1. So molality will have higher value. If molality will have higher value, then in practically the out value of I is less than 2. But for the calculation, we are using this value. And now I am putting, we have 1 plus 3 alpha is equal to I. So we have 1 plus 3 alpha is equal to I is equal to 2. So we have 3 alpha is equal to 1. Alpha is equal to 1 by 3. And for the percentage dissociation, it is 100 into alpha, 100 alpha. So this value is 100 by 3, that is 33.33%. So percentage dissociation for this reaction is 33% or little lesser than this value. If you put the exact value, the answer is less than 33.33. So you can answer it as 33 or simply 33.33. And the answer from JEE Advanced is in the range from 32 to 33.33. So this answer is definitely correct. If you write the answer by exact calculations, then that answer will be more correct. So our answer is coming to be 33.33. That's it. Thank you.